Find the particular solution of the differential equation dy by dx is equal to e to the 2x minus 3y, such that when x is equal to 0, y is equal to 1/3 ln of 5 over 2. Okay, so we've got dy by dx is equal to e to the 2x minus 3y. So what we need to do is to separate these variables by using rules of indices. So, okay, so you've got e to the 2x times e to the minus 3y, which we can write like that. And perhaps it might be easy if we wrote them as a fraction. So we've got e to the 2x over e to the 3y. Now it's very easy to separate the variables. So separating the variables, and this is the method used here, we're going to get e to the 3y dy by dx is equal to e to the 2x. So basically we're just taking that e to the 3y up there. Right, the next thing we do is we integrate both sides, and we're integrating both sides with respect to x. And that does seem a little bit strange, but if you put a dx here, obviously this will just become dy integral of e to the 3y dy. So you've got integral to the e to the 3y dy is equal to the integral of 2e to the 2x dx. Right, so continuing over here. Okay, so what we've got to remember, if we differentiate e to some function of x, it becomes f dashed of x e to the f of x. So if we integrate, like differentiate e to the 3y, then we're going to get an extra 3 in front. So to compensate, when you integrate, you need to put a 1/3 in front because of this rule here. So if you think now, if we differentiate that 3 will come down. We get 3 over 3 e to the 3y. So we get 1 times e to the 3y. We got back to what we started with. And similarly here, we get 1/2 e to the 2x. But we now must introduce a constant of integration. So we need to put it on one side or the other. Right, so if we say that e to the 3y is equal to e 3 over 2, okay, and that by taking that 3 up here times plus 3c. Now, using a to the c is equal to b, c is equal to ln of a. All right, we're going to get 3y is equal to ln to the 3 over 2 e to the 2x. And then we're going to change the constant 3c to a k. But we'll say that where k is equal to the 3c. And we'll call that equation 1. We'll stop there for a minute, and then we'll deal with the extra information that we're given, the boundary condition. So we've got when x is equal to 0, it must pass through this point. Y is equal to 1/3 ln of 5 over 2. So on this side, we're going to get 3 times 1/3 ln of 5 over 2. And then on the right-hand side, we're going to get ln of 3 over 2 e to the 2 times 0 plus k. Well, e to the 2 0 is 1. Okay, and then the 3's here will cancel. So that will just be an ln of 5 over 2. So this ln of 5 over 2 will have to be the same as 3 over 2 plus k, because this bit will be 1. Which means that k would have to be equal to 1, because 3 over 2 plus 1 makes 5 over 2. So from equation 1, and taking that 3 now and putting it in front, we're just going to get that y is 1/3 ln of 3 over 2 e to the 2x plus 1. So this has been a video to show you how to solve a differential equation by separating the variables and substituting in a condition. I hope you've understood, and I thank you very much for watching, and maybe you could consider subscribing to my channel. And if you want to watch any of my other videos, then just click the link which I put in the notes of this video. Thank you very much for watching.